Hello everyone, welcome back to Amaze. In this video, I am going to introduce pair of linear equations in two variables. So let's start with the introduction part, right? So first of all, what is the difference between 2x plus 3 and 2x plus 3 equals to 1? So basically, as you can see that there is a difference of this equal to 1 here, right? And we have already seen in the previous chapter, chapter number 2, right, that this type of expression is known as polynomial, right? While wherever we are having equal to sign and something is there in the LHS and in the RHS, this is known as an equation, right? Now, one more thing as you can compare it here is, what is the highest power of x here? That is 1. So as we have already studied that whenever we are having the highest power of x as 1 in the polynomial, that polynomial is known as linear polynomial. So similarly, in the equation, if the highest power of the variable is 1, then that type of equation is known as linear equation, right? So this is linear polynomial and this is linear equation. Now one more thing, here as you can see that this is a linear equation. How many variables are used here? So this is 2x plus 3 equals to 1, where only the one variable is there, which is x. And let's say if I am having an equation 2x plus 5y equals to 7, right? So here also the maximum power of the variable is 1 here. So this is also a linear equation and this is also a linear equation. But what is the basic difference between these two? So here as you can see that only one variable x is used here and there are two variables used here, which is x and y. So we can call this one as linear equation in one variable, because only one variable is used in this linear equation, and this is linear equation in two variables, right? So you are clear with this, that what do you mean by linear equation in two variables? So basically in this unit we are going to study about linear equation in two variables, okay? And I will be coming to the next point, which is pair of linear equations in two variables, okay? But before that, let's take one example of linear equation in two variables and we are going to see some facts about the same, okay? So let's do it. As we have studied in our last chapter that general form of the linear polynomial is ax plus b, where a cannot be equals to 0, right? So now here we will see what is the general form of the linear equation in two variables, right? So let's take one example, that is 2x plus y equals to 5, right? So this is a linear equation, yes, with two variables, yes, right? So now I can rearrange it and write it in the form 2x plus y minus 5 equals to 0, okay? Now this form, from this form we can write down the general form or standard form of linear equation in two variables. So the general form, or we can say it as standard form of linear equation in two variables is ax plus by plus c equals to 0, right? So here, as you can compare this to form where a is nothing but the coefficient of x, which is 2 here for this equation, b is nothing but the coefficient of y, which is 1 here, right? Because nothing is there, so plus 1 I can consider, so b value is 1, and c is the constant, which is minus 5 here. So this is the general form of linear equation in two variables, right, where the two variables are x and y. Here we cannot have a equals to 0 and b equals to 0. We cannot have this. So a should not be equals to 0 and b should not be equals to 0, right? Because if a will be 0, then 0 into x will be 0 and we will be left with only linear equation in one variable, that is y. And if b is 0, then we will be left with ax plus c, which is again a linear equation in one variable with variable x, right? So a should not be equals to 0 and b should not be equals to 0, right? So this is the standard form, or I can say general form of linear equation in two variables. Now let's see some more facts about the linear equation in two variables, okay? And I'm going to pick up these the same equation 2x plus y minus 5 equals to 0. So now let's see what we are getting. So now let's say we are having this example of linear equation in two variables, that is 2x plus y equals to 5, right, where the two variables are x and y. Now what are the values of x and y which I can take to satisfy this equation? Let's see. I'm making a table here and I'm going to write down few values which are satisfying this equation. So let's say if I'm taking x equals to 0, then 2 into 0 is 0. 0 plus what will be equals to 5? 0 plus, if I will take 5, then it will be equals to 5, right? So if I will take y equals to 5, this will satisfy the equation, right? 0 and 5, where x is 0 and y is 5, right? Because 2 into 0 is 0, 0 plus 5 is 5. Now let's say if I am taking 1, what we are going to get? 2 into 1 is 2, 2 plus what will be 5? 2 plus 3 will be 5. So whenever you are taking x equals to 1 and y equals to 3, again this is satisfying this particular equation, right? Now let's take x equals to 2. So what we are going to get? 2 into 2 is 4. 4 plus what will be equals to 5? 4 plus 1 will be equals to 5, right? So if I am taking x equals to 2 and y equals to 1, again this will satisfy this particular equation, right? Now let's take one more value. Let's take x equals to 3. So now what happens? 2 into 3 is 6. 6 plus what will be equals to 5? I can say that if I will take y equals to minus 1, then 6 plus minus 1 is nothing but 6 minus 1, which is 5, right? So now we have to take y as a negative number to satisfy this equation. So 2 into 3 is 6. 6 minus 1 will be equals to 5. So now, as you came to know from this that there will be no end to it. We can take any values, or we can take many values of x and y to satisfy this equation, right? So whatever the values are satisfying this equation are known as solution of the equation. So I can say the solution of this equation 2x plus y equals to 5 is 0, 5, okay, x, y, that is 0, 5, 1, 3, 2, 1 and so on. So we can have many solutions for this particular equation, right? So from this we can state that for any linear equation in two variables we can have infinitely many solutions, right? So we can have infinite number of solutions for a linear equation in two variables. right? Now, as we have seen that this equation has infinitely many solutions, let's see graphically how we can represent this. So let's make a graph. Okay, this is x and y axis, right? Now I'm going to take few numbers here: 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 7, right? Now to plot this, what we can do is we can substitute, or we can plot these points onto the graph. Okay, and we require only 2 points to make a line, and you are already aware about it that whenever you plot a linear equation, you will get a straight line, because linear equation graphically represents a straight line only, right? So let's plot 0, 5, where it is 0, 5, here it is. Okay, 1, 3, where it is 1, 3, it is here, right? So only 2 points are enough to make a straight line, right? So it will pass through like this. Okay, so this is a line representing this equation: 2x plus y equals to 5, right? Now what can you say from this graph? Look at the other values: 2, 1. So where is 2, 1? 2, 1, here it is. Okay, 3, minus 1. So 3, minus 1, here it is. This is minus 1. So all these solutions which you have taken out are the points on this line. That means that all the points on this lines, all the points are representing solution of this linear equation. So remember that whenever you are plotting a linear equation, you will get a line, and all the points on that line will be the solution of the given equation, right? And as you know that how many points are there on a line? Infinite points. And I told you that each point is a solution of the equation. So how many solutions we can have? Infinitely many solutions. Clear? So one more time I am going to repeat here is that on a line which is representing a particular equation, there are infinite number of points. Each point is showing the solution of the given equation, and there are infinite points on a line. Therefore we can say that we have infinitely many solutions for a particular linear equation. Clear? So this is how we can represent a particular situation in a algebraic form, and this is the graphical form of the same, right? So we have seen if there is a particular linear equation, how we can graph it, right? And next I am going to cover pair of linear equations in 2 variables. So we have seen a linear equation in 2 variables. Now what do you mean by pair of linear equation in 2 variables, which we are going to cover next. So let's see it, and let's see some facts about the same. So now we know that what do you mean by linear equation in 2 variables. Now we are going to see what do you mean by pair of linear equations in 2 variables. So pair means what? 2, right? So if we are having 2 linear equations in 2 variables, then we call it as pair of linear equation in 2 variables. Let me write down one example here. Let's say if I am having one equation as 2x plus y minus 5 equals to 0, and the other equation as x plus 2y minus 4 equals to 0. So as you can see, I have written both the equations in the general form, and as both of them are linear equations in 2 variables, we call it as pair of linear equation in 2 variables, right? Forming a pair because there are 2 equations. Now the next part is we have studied the standard form of linear equation in two variables. The standard form is ax plus by plus c equals to 0, right? Now here, in pair of linear equation in two variables, we are going to have two equations. So the other equation will be also of the form ax plus by plus c equals to 0, right? And as there are two equations with the same variables x and y, to differentiate these two equations in the general form, what we can write here is a1, b1, c1 and a2, b2 and c2. That means I can differentiate here that the value of a1 is 2, b1 is 1 here and c1 is minus 5 for the first equation. So I have written a1, b1 and c1. Okay, a2, b2, c2 are the values of a, b and c for the second equation. So what is a2? 1. What is b2? 2. And what is c2? That is negative 4. Right? So the pair of linear equation in two variables can be represented in this manner. Right? Now the next thing is, we have seen that if we are representing any of the linear equation on a graph, it will form a straight line. Right? But here we are having two equations. So two equations means one line for this equation, okay, and one line for this equation, right? So we are going to have two lines on the graph. So there are three cases if we have two lines on the graph. Which are the three cases? We can have intersecting lines on the graph, okay, like this. Yes, we can have intersecting lines. One line will be the representation of one equation and the other line will be the representation of the other equation. We can have intersecting lines if we have two lines on the graph. Second case, what we can have? Parallel lines. So obviously, if two lines are there, we can have one of the case as parallel lines where they do not meet at any point of time, right? Okay, so this is the second case. And the third case we can have is coincident lines. Coincident lines means first equation and the second equation also represents the same line, okay, means they are coinciding on each other. Both the lines are representing the same points, okay, are formed by the same points. That means both are lying on each other. So these are known as coincident lines. So these three cases are possible for a pair of linear equation in two variables. Okay, again I am repeating, we can have two lines for a pair of linear equation in two variables onto the graph. So there are three cases onto the graph. We can have both the lines intersecting, we can have both the lines parallel, or we can have both the lines coinciding on each other, right? So now we are done with the introduction part of pair of linear equation in two variables. In the next video, I am going to cover some question from exercise 3.1, and then we are going to see graphical method to find out a solution of a pair of linear equation in two variables. And next I am going to take few important questions from exercise 3.2, right? So that's it for this video. Thank you. Catch me up in the next video.